One routinely overlooked aspect of guns that I think needs to be appreciated more in video games is how developers are able to synchronize their fire rate and able to make them as they're advertised to their player base. If you just think about it for a second, when it comes to PC gaming especially, you have people that are on vastly different systems. They have even vastly different internet connection. You have some people with low ping, low FPS, and some with high ping and high FPS. But how are they all able to shoot the same gun and it comes out the exact same time? The key thing here is synchronization. And that is something that I learned the hard way when I was working on my game project at the moment. Something that I used in order to synchronize my scripts, both client side and server side, is through a synchronized clock as well as tick rate. But we'll get into more of that in just a little bit. First, I want to show you the problem that I faced. In Unity, I have a gun which has the set fire rate of 600 RPM. That means that ideally it's going to shoot one bullet every 0.1 seconds. But when I was testing it out and firing continuously with no stops, I realized that my fire rate was actually slower than I intended it to be. It was somewhere around the ballpark of 550 RPM. And that may not sound like a lot, but in a fast-paced multiplayer shooter game, where even a few milliseconds of difference can change the course of a game, having slower fire rate than what the gun is advertised as is a game-breaking feature or a game-breaking bug. It's something that needs to be fixed. So how I came to fix this was actually quite interesting, and it gave me much greater appreciation for synchronization and time-sensitive activities within game development. Another thing I want to talk about is tick rate. When it comes to multiplayer networking, we typically use ticks and not an internal clock. The reason why we use ticks is because ticks are a fixed unit of time measurement, and that, of course, for synchronization is perfect. If we were to synchronize things and what the player sees based on their individual timers, there will be very small margins of error because everyone's internal clock will be slightly different from someone else's, and therefore that will create those few milliseconds of difference which are crucial to having a nice multiplayer experience. Hence why ticks, being a fixed interval of time, solves that, and it solves a bunch of desynchronization problems, it solves lag compensation, and it solves host migration. So I want to talk you through some of the various solutions that I implemented both for my client-side facing script and my server-side facing script. So I'm here in my Unity game project. Never mind the code too much because I intend to talk about all facets of my code in future episodes, but for right now we're only concerned with fire rate synchronization. This is my client-side script. So in this script, I'm going to be focusing strictly on taking user input. The reason why we have client-side script in Unity is because we want the actions to feel responsive and snappy. We want the user to feel like they are in full control of their character. And inshallah, I plan on creating a game in order to rival Call of Duty Zombies. I want to create basically a standalone zombies game, and for that I need to use every single trick under the sun in order to be able to create a game to be able to rival that. So I need to use industry standard design principles, and one for that is having a client-side server-side script. So within my client-side script, I have this fire rate, which in the inspector I've set this to 600 RPM already. And then I have two additional variables, last time fired and fire cooldown. Last time fired essentially just keeps track of when the gun was last shot within the network simulation, and fire cooldown is responsible for the time between each bullet. The time between each bullet, essentially. So if the gun is 600 RPM, that means that the fire cooldown will be 0.1 seconds. Over here in the awake functions, this is where I set it. Crucially, last time fired uses time.time and not time.delta time. Within time.delta time, there is the possibility of variance, whereas time.time, as you can read from the description here, it's the time at the beginning of the current frame in seconds since the start of the application. This is very crucial. This means that every single object within the Unity simulation will have the same start of application, regardless of when it was instantiated, regardless of what internal time it may currently have. So time.time, when you're doing a client-side facing script, is best for this type of synchronization. And of course, fire cooldown uses this formula. And then when I go into my update function, so of course, never mind this, all you need to know is that this method is being called every update by another script. I have this boolean value, which is by default set to false, which determines whether or not the gun has actually been shot or not. I am fetching an input from the Unity input system, and then I'm checking if the current time of the application is greater than the last time the gun was fired. If all of this is set to true, then I set the boolean value to true, so that means the gun has fired. And I set the last time the gun fired to be the current time of the application plus the fire cooldown, which in this case will be 0.1 second. And that is how I managed to synchronize my fire rate for my client side. But now, how do we do that for server side? Because for server side, like I mentioned, we don't use time, we use tick rate. And with tick rate, the logic is slightly different, but still similar enough. So I'm over here within my network-facing script. So this is the script that's responsible for validating the user's input from the server and, of course, ensuring synchronization. And for the networking side, we need to use tick rate, not a timer. So in order for me to explain to you how I solved this problem, I want to explain to you my concept of frame depth. So bear with me for a moment, because I don't know what the technical term for this would be, but imagine, for example, there are people lining up for a concert. The concert can only take a set number of people at a time, but the concert simultaneously also need to meet a quota of people during that time frame. So say, for example, the concert wants to bring in people at a rate of 10 every minute. That means every single minute 10 people are entering the stadium. But you want them to enter, of course, slowly. You can't just flood them in, because due to safety and rules and regulations, you can't just, bring the entire city in and cause a stampede. So we want to bring in 10 people into the concert per minute, but due to some weird limitation of the hallway that we're using, we can only bring a batch of people in every 15 seconds. And of course, in order to control traffic well, we want to bring an equal batch. Since we only have four 15-second intervals to bring someone into the concert, that means we bring 2.5 people in through the corridor every 15 seconds to reach the quota of 10 per minute. But of course, there is no such thing as half a person. You can't really do that. So you would edge on the safer side of things, and you would only bring 2 people into the hallway when you let them go. Now, of course, if you were to do that every single time, you would only end up with 8 people, so you fall too short of your quota, and then the stadium ends up being underpopulated, and by the time those people that were meant to enter the stadium have entered, the concert is already over. You have went overtime, and you have failed your job as like the concert manager or the bouncer, for example. This is where I, for example, am using the concept of depth. I don't really know if there's a correct technical term for it, which is essentially if we have a residual amount of people that we want to bring in, we instead go to the lower end of the spectrum so that we have a whole number, but we also remember that residual and add that residual onto our next batch that we bring in, so that way we're all able to meet our quota. So with the first batch we bring 2 people in because we're bringing in at a rate of 2.5. We can't do half a person, so we bring 2 people in, but we carry over the residual of 0.5. Then in the next batch, when we bring another 2.5 people in, we add that residual of 0.5, making it 3. So in the next batch, we bring 3 people in instead of 2. And we carry on this formula, and we're able to keep going, and we're able to meet the quota of 10 people per minute. That's exactly what I'm doing here with the concept of frame depth. So in my network-facing script, I have fire rate. Then I have true fire rate per tick. This is basically the equivalent of the quota that we're trying to meet. If I scroll down here, this is the tick rate, which I've hard-coded here at being 64, then divided by the fire rate divided by 60 in order to get the fire rate from minute to the fire rate per second. So this, with a 600 RPM gun, this will work out to 6.4. Then we get the fire rate ticks. This is then, in that concert example, we're going on the safer side and we're going down to the lower whole number. This is what the point of this is. And then the frame depth is basically that residual that we were doing from beforehand. So this is how we calculate our frame depth and our fire rate per tick. And then in our update function, this is the photon fusion to equivalent of the update function. We are of course checking for the input, and then we ensure that the current network tick is greater than the next fire tick, which is basically the equivalent of when the gun was last fired. This is initiated at the very beginning to be at 0, or at the start of the application, plus the residual frame depth that we have got going on. And if that's all well and good, then we set the next fire tick. Of course, I don't mind too much the code here because there's a lot of additional stuff that I'm doing. We take the next fire tick, we make it the current runner tick. Sorry, it's this one over here. We make it the current runner tick, and then we add our true fire rate tick, and then we update our frame depth accordingly, so that we make sure that we're taking into account the residual that's going forward. Yeah, it was really exciting. It was really fun to be able to solve this, and I hope to bring you more of my game dev journey in the future. Thank you for your time.